there she blows. I don't get tides like that. There are almost no tides in the Gulf of Mexico. Well, here it's normally between an 8 and 10 metre swing, which is quite a lot really, but you get some great data with it as well, so it's like we never really see any kind of bottom-up obstruction here, apart from down in the cove down there in Haitian, you know where the bottleneck is, and we get that tidal bore. It's like I can film here off the steps, I can film the lighthouse in Barrow when obviously you can see it, and I'm further away and I can film it from say 3 feet above sea level, not a problem. But then I go nearer to the lighthouse, about 2 miles or 2.5 miles down this way, so I'm way nearer to the lighthouse, and I get obstruction by the water. You know, and that's what set me on the track of thinking, well, what the hell is going on here? And that's what made me look into the effects of the tides and stuff, you know. And here, for instance, you know, I mean, I was seeing something that was, you know, what Globers would have claimed and have claimed is bottom-up obstruction, and it was just the tidal surge as it goes up that channel. And of course now we know all this other stuff we've got. As you look out to the ocean now, you've got to appreciate that we've got a swell happening, even though you don't see it. As you look out, there is a swell happening on the water. It's going up and down by as much as a couple of meters. And when your feet are stood right next to the water there, you think you're at sea level, but you're not, because the water in front of you is rising up and down by as much as a couple of meters, and that's just the swell. That's not even taking into account the actual waves. And then you've got to add the wave heights on top. Oh, I know where I am. Each one has a different reference. I think the one next is BLO 96, then you got BLO 95, and it's so that if you get in trouble and you see somebody drowning or something, you can give the number to the Coast Guard and they'll know exactly where to come to. So yeah, BLO 97, and I was down on the embankment just down there. Boat is still visible. Yeah, one other thing to think about as well is that it's called shoaling. I don't know if you guys have come across that term before, but it's something that I found out recently. And if you look into it, the term shoaling, what it actually means is that obviously when we go out there, it's deeper than right here. So shallow water here, deeper and deeper the further away you go. So this boat right now that I'm filming, this boat right here, is in much deeper water than the water around here, which means that it's on a slant. Like so. So as the tide's coming in, from out there, it's coming across the slant, it's meeting resistance, because the floor is the resistance. So you've got the tide pushing in against this slope, and this is the shoaling effect. And what happens is you get straight up vertical movement of the water. So it has to be pushed up because you've got a huge volume of water trying to go up against a shelf like so, and it's called shoaling, and it's called vertical displacement of the water. So that will cause a hump like so, like an artificial hump as it comes in, and on the recede, when it goes back out, it's the same thing. You've got the water trying to push its way out, but it's meeting resistance from the deep water this time. And what happens then is it pools again in the same area, so you get this constant localized bulge all around. And everybody has that, every continent has that. Every single continent has the same shoaling effect. Sparky Lee, nice to see you in. Gleam. Yeah, Gleam, exactly Gleam. They installed loads of rocks in Bournemouth to recreate this natural thing, but it also makes the surf waves higher. Exactly. When the water's pushing in, it meets resistance, and it doesn't matter whether it's a bunch of rocks at the bottom, or it doesn't matter whether it's actually the actual shape of the actual terrain underneath the water. So if the shape of the terrain underneath the water is like so, it is going to get shoaling, higher waves, blockage. It's going to get blockage, and every continent has that. Every single continent goes from shallow to deep, and every continent has tides, and it's so bloody obvious now. No boat has ever gone over the curvature of the Earth, ever. And look at that in the inferior mirage. You guys, can you see that? Can you see the inferior mirage on the boat now? Absolutely crystal clear. Check out the Bay of Fundy, the tide change is about 50 feet. Really? That's higher than here, really? 50 feet. Wow. But the problem is, and this is the thing, is that every single continent, every place in the world has swell. You have swell. Always have swell. You've got to take account of the swell. The amplitude of the swell is always half the height of the swell. So if you research right now and you look at what the swell is in where I am now, the Irish Sea, let's suppose that it's just half a metre. Let's suppose we've got half a metre of swell right now. Well, that means that a quarter of the metre is above the level, down there, you know, if I was standing by the water's edge. So a quarter of that would be up, a quarter of the metre up, and a quarter of it would be down, and that would be blockage, and that's to add on top of the height of the waves. And in different locations you get an awful lot more. I mean, I was just been doing some recently from where Wolfie does his filming, and where's that boat gone? There it is. And Rottnest Island, you can search it there. You can literally look up Rottnest Island, willysomething.com. I think it's the second one down. And it will tell you what the swell is for that location for Rottnest Island. And typically it's around about 2.2 metres, which means that at least 1 metre is vertical up of amplitude and 1 metre of it is down. So it's up and down, up and down. So 1 metre is above where your toes are on the shoreline, because if the swell up and down like so, you've got a metre up, a metre down. Yeah? So if you've got your tripod set to 3 foot, right down there at the water's edge, and you've got a swell of 2 metres, that means you've got 1 metre of vertical amplitude. You have to be looking up and over the waves to see anything in the distance, and that's not even taking into account the height of the waves. And the waves can be measured because they're normally wind driven, and they're done on the speed of the wind. So if you've got a 25-mile-an-hour wind, you can expect 8-foot high waves. 8 foot high, which means 4 foot is the amplitude, so there's another 4 foot to stick on top of the swell. Look it up, guys. I'm not lying. This is definitely out there. So anytime they want to give us a measurement and they say, what's your height above sea level? And you say, oh well, I'm 3 foot above sea level down there, right where my finger is down there. You are where your feet is. You think you're 3 feet above sea level, but the water out here raises up, goes higher. Right guys, I'm going to knock this live stream on the head now. Thanks everybody for stopping by. I'll be on at Nathan's at 2 o'clock. We'll have a chat there. Got some interesting stuff to show you. And yeah, just a few more shout outs before I go. Trouble About, nice to see you in. Nice to see you in, Doc Michael. Flatlander, nice to see you in, mate. And I think I've said hello to everybody else. If I have missed anybody, I do apologise. But yeah, we'll see you in the next one, guys. So the time right now is 12:50. Right, so bear with me. We have 43 steps down to the incoming tide. The tide is around about 1.5 feet beneath those steps. So I'm going to get a measurement on each step, and then we'll know my elevation above sea level. So just give me a sec. So we have 23 steps, and each step is 7 inches. And the centre of the camera now is 32 inches off the actual floor. So we have 32 inches to add on to 7 times 23. What's that? 140, 161. 171, 181, 184 inches down to the sands, or around about 1.5 feet above that, so another 18 inches. So we can plot all that detail in. Time right now is 12:52. We can track that boat. That's the sea truck. I mean, it's close to have gone right now, I think. Don't know if I can zoom in any further and re-find it.